All right, guys, this is Northern Oklahoma College Algebra Math 1513, Chapter 2, Section 2, and we're going to finish up with a nice, easy lesson about how to identify intervals over which a function is increasing, that means going up, constant, that means remaining level, or decreasing, going down. All right, let's do a quick review about interval notation. Let's say I want to talk about the interval from 2 to 5. Now, back in junior high, maybe you put open circles on it and shaded in between. And then in college, we got our 2 and our 5, and we say, okay, I don't want to include 2 and 5, so I use parentheses and shade in between. Now, the interval notation for saying either one of those is I want the interval from 2 to 5. 2 is not included, and 5 is not included. So that's the interval from 2 to 5. What about the interval from, let's say, 2 to 5, and I want to include 2, but I don't want to include 5. So that's my interval right there. Well, I would write 2 to 5. I'm going to include 2 by using brackets, but I'm not going to include 5 by using parentheses. And finally, you guys remember good old infinity. Let's say we have 5, and I want to go out to infinity, and I want to include 5. How would I represent that in interval notation? It's the interval from 5 to positive infinity. Remember, we can never enclose infinity because we don't know where it is, but 5 is included, so I want to put brackets around the 5. So from 5 to infinity. All right, what about this graph right here? This is a function, and we're just going to name it good old f. This is the f function. This is what it does. This is what it looks like on the graph. And I want to know what f is doing, when it is increasing and when it is decreasing, and if and when it's remaining constant. Well, f is obviously, now, how do we read the graph? We read the graph from left to right, just like we read a book. So going from left to right, even though that arrow is pointed down, when we go from left to right, the graph is obviously increasing up to this point. So it's increasing. And then from that point on, it goes downhill and it's decreasing. Okay, so increasing and decreasing. Okay, how do we express this? We express this by looking at the x-axis. I want to know the domain, or the x's for which it's increasing and the x's for which it's decreasing. So it looks to me, if I'm on the x-axis, it looks to me like it's increasing to this point right here. What point is that? That's the point x equals 0. So, and out to this way, it goes on forever to the left. That's the point negative infinity. So how do we express that interval? We just talked about that. It is increasing on the interval from negative infinity to 0. Infinity can't be included, and 0 actually is included. Okay, and when is it decreasing? It's decreasing from this point, 0, out to infinity. So decreasing on the interval from 0 out to positive infinity. Infinity cannot be included, so it's a parentheses. 0 is included, so it's a bracket. How about this one? Let's call this g. It's just the function g. And tell me what's happening. Well, as we go left to right, remember when you're reading a graph, you go left to right. As we go left to right, it's increasing on this interval here. So increasing. What is that interval? Well, the increase appears to stop right here. At that point, it starts going constant. So it increases from that point. So if we look at the number line, we're talking about from here out to negative infinity, that interval right there. So our function g is increasing from negative infinity to which x value? Well, if we look at our graph here, -1, -2, -3, it increases until it hits x -3. -3 is included, infinity is never included. All right, look at the next piece of the graph. From here to here, it's remaining constant, okay? Now what x values does that include? Well, that includes the x values from -3 to +2. So let's write that. Our graph is constant, or remains constant. Whoops, that's wrong. Our graph remains constant from the x of -3 to the x of +2, and both are included. When you're talking about whether the graph is increasing or constant or decreasing, we include the points where it makes a turn and changes. What about our final piece of the graph here? Our final piece of the graph is decreasing. Now what x values are we talking about? We're talking about from the x +2 out to +infinity. So we are decreasing on the interval from the x of +2 out to the x of +infinity. Infinity is never included, our 2 is included. So increasing from -infinity until it hits -3, from here to here, and then it remains constant from an x of -3 to an x of +2, and then it decreases from an x of +2 out to infinity. And finally, for our final example, here's a -x³ graph. You guys can see I graphed it up here, -x³. I just put this one on here because it might try and trick you a little bit. All right, we are reading the graph from left to right and trying to examine what it's doing. So going from left to right, it is decreasing, 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 decreasing. Now this is the point that fools most people. They think at that point it becomes constant. But you know what? It actually never stops decreasing. So it continues decreasing. Now the decrease is very slight, but it's still decreasing, and then it decreases steeper and steeper and steeper. So this graph is actually decreasing all the way. Now what x values are we talking about? Well, eventually it's going to wind up way out there at -infinity. So we're talking about from -infinity to the x value of +infinity, because eventually they will work their way out there. So what is our interval? It is decreasing, because it's going down the whole way, along the interval from -infinity all the way to +infinity. Parentheses around both, we can't include infinity. And remember, the only reason I show you this, and you'll see this in your homework, is because it appears to go constant right there, but it never actually stops decreasing. It's kind of a trick.